All right, let's talk about one of the biggest decisions you're ever going to make, choosing your specialization. I mean, this isn't just picking a major, right? You're basically setting the course for your entire future. So what if you could pick a path that puts you right at the bleeding edge of the next tech revolution? Sound interesting? Okay, let's dive in.
Because honestly, that's exactly what we're talking about. The digital world, the one we've built everything on, well, it's kind of hitting a wall, a hard one. And that means we are right on the verge of this massive, fundamental shift in how we do, well, everything. How we process information, how we solve problems, it's all about to change.
You know, for decades, we've had our trusty classical computers. And don't get me wrong, they've been incredible. They've changed the world. But they're reaching their physical limits. I mean, you can only shrink a transistor so much before you're dealing with individual atoms. And that's where this new door swings wide open to a totally new paradigm, quantum computing. And the key thing to get here is that this isn't just a faster version of your laptop. It is a completely different way of thinking about computation itself.
And look, this is not some pie-in-the-sky academic theory we're talking about. No way. The race is on, right now. You've got the biggest names in the game, IBM, Google, Microsoft, Intel. They are pouring billions of dollars into this, all of them scrambling to build the first truly powerful quantum machine. You know, when you see rivals like that all betting the farm on the same future, you know something huge is about to happen.
Okay, so here's the best part. Here's what this means for you. Because this whole field is so incredibly new, the playing field, it's wide open. It's not saturated. Getting in now as one of the early learners, that gives you a massive advantage. This is a rare, unique chance to get in on the ground floor of what's absolutely going to be the next big thing in tech.
All right, so what is quantum computing really? The name itself sounds intense, right? Kind of intimidating. I totally get it, but stick with me because we're going to break down the core ideas, we're going to strip away the scary physics, and get to the stuff that's actually pretty easy to wrap your head around.
It really all starts with one thing, the qubit. So you know how your computer, your phone, everything, it all runs on bits, right? Little switches that are either a 1 or a 0. Well, a quantum computer uses a qubit. And believe it or not, this one little change in the basic building block, that's the key that unlocks all that mind-blowing power we've been talking about.
So, what makes a qubit so special? Well, it has these, you could almost call them superpowers. First up is superposition. This means a qubit can be a 1, a 0, or kinda both at the same time. This lets it explore a huge number of possibilities all at once. Now get this. To put that in perspective, a quantum computer with just 300 of these qubits could juggle more combinations than there are atoms in the entire known universe. Yeah, let that sink in. Then you have entanglement, where two qubits become linked. What happens to one instantly affects the other, even if they're miles apart. It's wild. And finally, there's interference, which is a clever way the computer cancels out the wrong answers and boosts the signal for the right one. You put these three things together and suddenly you can solve problems that a classical computer wouldn't finish in the lifetime of the universe. And that mix of ideas, that's exactly why this field is so cool. This isn't just for theoretical physicists locked away in a lab somewhere, not at all. It's this amazing mashup of physics, computer science, and mathematics. So if you're someone who loves seeing how different fields can click together to solve really, really big problems, then yeah, this is exactly where you belong.
Okay, so that's the what. That's the theory. But so what? Why does any of this actually matter? Well, it matters because of what this technology can actually do in the real world. We're talking about the power to tackle some of the biggest, gnarliest problems that humanity has ever faced.
I mean, the potential here is just staggering. Seriously, we're talking about creating unbreakable codes that could secure all of our data. We're talking about designing life-saving new medicines. Think about it. Trying to simulate just one complex molecule to create a new drug, that's a job that would bring today's best supercomputers to their knees. But for a quantum computer, that's exactly the kind of problem it's born to solve. And it doesn't stop there. This same power could supercharge AI, crack impossible financial problems, and even give us the tools to finally get a handle on climate change.
Let's just zoom in on one of those for a second. AI. We all know it's a field with incredible promise, right? But it also comes with a lot of anxiety, a lot of scary headlines, and it's all kind of summed up by warnings like this famous one from the late, great Stephen Hawking.
But here's a really hopeful thought. The completely unique way that quantum computers solve problems, it might just give us a way to steer AI's development in a better direction. The hope is that by training these AI models in a fundamentally new way, we could unlock solutions that are not only more powerful but also safer. It really could be one of the key tools that helps us get AI right.
Okay, so let's bring this whole conversation back to you. We've talked about the coming revolution. We've talked about the wild technology. Now, how do you actually get involved? What does a career in this quantum world even look like?
Well, first off, you're going to gain an absolutely incredible, high-demand skill set. And sure, you'll get a solid foundation in the science and the math, but you'll also get your hands dirty programming on real quantum platforms like Qiskit and Cirq. But you know what's even more important? You'll learn a whole new way of thinking, a kind of abstract, creative problem-solving that's going to be essential for anyone designing the algorithms of the future.
And with skills like that, a huge range of career paths just open right up for you. You could be a research scientist in academia, discovering the next breakthrough, or a quantum software developer at a place like Google, tackling climate change. Maybe you're a hardware engineer at a cool new startup, literally building the qubits themselves. Or a cybersecurity expert for the government, creating encryption that nobody can break. The point is, this specialization opens doors in every sector.
So let's wrap this up by circling all the way back to where we started. Back to that big decision. With all the possible majors and specializations out there, why choose this one? Why bet your future on quantum? Here's why. Because this is a chance to do so much more than just get a good job. This is an opportunity to be a pioneer, a real one. The people who are studying this stuff right now are the ones who are going to build the world of tomorrow. You won't just be watching the next technological era happen, you'll be one of the people actually creating it.
This revolution isn't coming, it's already here. It's happening right now. So the only question left is the one on the screen. Are you ready to be a pioneer?